This brings us to Marlene Hsu. As an innovation manager at ISLE, Marlene looks at the iceberg of water challenges, the aging infrastructure and climate impacts we see on the surface, and the technical and societal drivers below. In this mini lecture, she explains how university research and development can ensure the next 30 years of innovation are even more impactful than the last. Marlene, thank you very much for joining us today. I saw your report for the University of New South Wales and I was captivated by your vision for research in the service of society. And I begged you to share your vision and passion with the audience here. You kindly agreed to give a 5-minute mini lecture. Are you set to do it?
I am, Jo. Thank you very much for that. I'm Marlene Hsu, Innovation Manager at ISLE. I work at the intersection of research, innovation, and real-world implementation in the water sector. My recent focus has been on accelerating the adoption of emerging technologies and shaping strategies and collaborative programs that address complex urban water challenges. Today's presentation unpacks the commercial and societal potential of UNSW's water-related research, positioning the tertiary sector as a key deliverer of global water sector innovation. We'll highlight some of the high potential opportunities and outline a strategic roadmap for translating these findings into high-impact commercial partnerships. Universities and research institutes have advanced the global water sector by bridging fundamental science with real-world solutions. Academic research pioneered membrane filtration for desalination, now deployed at scale in water-scarce regions including Australia, the Middle East, California, and Singapore. In recent years, universities have faced severe challenges. Funding cuts have reduced research infrastructure maintenance, talent attraction, and innovation support. In the UK, 50% of universities have closed courses, with 70% considering further reductions. The COVID-19 pandemic exacerbated these pressures through dramatic declines in international student intakes, a critical revenue stream. Australian universities lost 10% of their workforce and experienced a 40% drop in overseas enrolments between 2019 and 2022, severely limiting the sector's capacity to advance emerging technologies. The University of New South Wales in Sydney has conducted water research for over 75 years, establishing itself as a leading centre of expertise globally. It houses the Global Water Institute, one of Australia's most advanced water knowledge hubs with multidisciplinary reach across engineering, science, law, business, and social sciences. UNSW leads in water treatment research, wastewater reuse, stormwater harvesting, and nature-based solutions with work through its Water Research Centre and Laboratory, strengthening water security in Australia and worldwide. ISLE's engagement was to review UNSW's water-related R&D portfolio and identify capabilities for new partnerships or spin-out technologies. This wasn't the first time that we had done a piece of work like this, having delivered similar strategic mapping outcomes for water, utility, government and industry partners in the past. We drew on specialised literature and global water data to establish the overarching trends and drivers reshaping the sector. This was critically supplemented by utility discussions and input from our network of industry partners globally, ensuring the findings were grounded in real-world operational challenges and market needs. This dual approach allowed us to present a validated review of the trends influencing the future direction of water-related research. To illustrate this review, we used an iceberg metaphor to frame the global urban water challenges. The visible tip of the iceberg includes immediate threats like adapting to droughts and floods and replacing aging infrastructure. The vast majority, the below-the-surface segment, comprises interconnected drivers, severe climate impacts, resource scarcity, and technical and societal challenges of integrating smart asset management and digital solutions. Our review of UNSW's research revealed high potential expertise poised for commercialisation across 5 engineering schools: civil and environmental engineering, mechanical and manufacturing engineering, electrical and telecommunications engineering, chemical engineering, and minerals and energy resources engineering. We grouped these capabilities into 6 main areas. Key discoveries highlighted a strong alignment between UNSW's unique strengths, such as modelling and analysis of water movement through rock and other porous media, hydraulics, self-healing concrete, and advanced corrosion technologies, and the acute challenges faced by water utilities. UNSW also offers deep expertise in next-generation coastal solutions, working with the School of Biological and Environmental Sciences, advanced sensors for complex waters, and predictive digital twins for proactive asset management. Crucially, these capabilities possess significant cross-sector potential, supporting commercialisation via licensing, startups, and joint ventures with water-dependent industries. Strategically, working with water-adjacent industries offers traditionally water-focused businesses access to technological advancements, processes, or resources that can be found in other sectors. ISLE's work aims to draw out the unique strengths of individual clients. Our findings pointed to several high-potential themes for urban water sector: novel materials, eco-engineering, optimizing water treatment, net zero and resource optimization, asset performance and condition monitoring, as well as software applications in the water sector. Within these themes, we identified specific high-potential project areas. Strengthening partnerships with water utilities and water-dependent industries will reveal new segments and applications for industry-ready technology spin-outs, creating new commercialization pathways. Establishing new research partnerships in water-adjacent sectors also provides students with opportunities to undertake research that has real societal and environmental impact, helping them to graduate more workforce ready. Universities play a vital role in turning research into real-world impact, and there are several pathways through which this commercialization can occur. These include licensing, where intellectual property is granted to existing companies, startup creation, which builds new enterprises around university innovations, joint ventures, enabling collaborative projects with industry partners, and consulting or contract research, where academic expertise is applied directly to solve industry challenges. Together, these routes ensure that discoveries made in the tertiary sector are translated into practical solutions, driving innovation, economic growth, and societal benefit.
Marlene, that's absolutely fantastic. I love it. As someone whose PhD was done on a real problem for a water company, Yorkshire Water in the UK, and I could see at the end of 3 years the difference it made. That got me hooked on the idea of academic research for practical reasons. Nobody writes a thesis just to put it on a shelf. And I think what you said embodies the image of science in the service of the natural world and society. Thank you so much for sharing that with us.
No problem. It's my pleasure.
Marlene's strategic roadmap gives us a framework for how we take advanced research like modelling water movement in porous media or next-gen sensors and turn it into a commercial reality. It's about ensuring that the science in the service of society actually reaches the people who need it.